I am opening the next page. There is a problem based on this formula. That is the trigonometric ratios of 360 degree minus theta and this screen is visible, I hope.
Sir,
And
yes.
now the problem is find the values of other 5 trigonometric functions. If secant of x is 13 by 5, x lies in the fourth quadrant. So angle x measured from the positive direction of x-axis is an angle in the fourth quadrant as shown here. So this is an angle lying between 270 degree and 360 degrees. Again, if the complete angle we take, that is 360 degree, other than the angle x, remaining part in the complete angle, if we let it equal to theta, we can say that x is equal to 360 degree minus theta, as is clear from the diagram also. So we are given secant of x. Secant of x is given 13 by 5, and secant of 360 degree minus theta should be 13 of 5, and we know the formula secant 360 degree minus theta is same as secant theta. So secant theta is 13 by 5. Now secant theta is 13 by 5. We can make a basic triangle. So this is a right triangle. This is angle theta. Secant theta 13 by 5, that is hypotenuse divided by base is 13 by 5. It means that hypotenuse is 13, base is 5. By Pythagoras theorem, we can find the perpendicular equal to 12, because 13 square minus 5 square under the root. This is the value of the perpendicular. So therefore, we can write sine theta is equal to 12 upon 13. So sine of x means sine of 360 degree minus theta. This is equal to minus sine theta. So this is minus 12 by 30. Its reciprocal we find side by side. Cosec x will be negative this minus 13 by 12, the reciprocal of sine x. Secant secant x is already given 13 by 5. So cos of x is the reciprocal of secant. So 5 by 30. And tan of x is, before that we find tan theta. Tan theta means perpendicular upon base, 12 by 5. Therefore tan of x is equal to tan of 360 degree minus theta. That is, we have found it to be minus tan theta. So this is minus 12 by 5. And so finally its reciprocal cot of x is equal to minus 5 by 12. I hope this solution of the problem is clear to all of you. Yes, Navraj?
Sir, yes.
Man? And anyone having doubt? Otherwise, take the screenshot. I can go further. So I am closing the screen. Sharing the next screen. Is this visible? Yes. Anmol,
Yes, sir.
Gurman, Arpan. So this is the new topic. Means chapter is same. We are doing trigonometry. In this is a new topic. Modern concept of angle. And angle is the measure of rotation in this concept. You can think of a wheel. Wheel rotates. Suppose this left hand side circle is representing a wheel. There is a point P on the periphery of the wheel. As the wheel starts rotating about its center, the point will move on the periphery. So angle will be formed. As wheel rotates further, the point will go, suppose here. Larger angle will be formed. Let us take another position of the point. Suppose the point has reached this position. So the angle formed is this much. What I want to say, angle described can be acute, angle can be obtuse, angle can be reflex also more than 180. Angle can be 360-degree, that is complete angle also in the modern concept of angle. And even more, the angle can be more than 360-degree also. Can you understand this point? Suppose the wheel has completed. Suppose that the wheel has completed one rotation. Suppose the wheel has completed one rotation, but wheel has not stopped rotating. Wheel is going on to complete the second rotation also. After completing the one rotation, wheel continues rotating. So what will be the angle formed? Suppose this much angle. Suppose I take by different colors. Suppose this green color. This much angle is suppose 80-degree in the first rotation. But if the wheel completes one rotation, that means 360-degree. Then after 360-degree, it rotates 80-degree more. The angle will be 360-degree plus 80-degree equal to 440-degree. Understand? This is a new concept for all of you. Tell me, angle can have any size. Gurjot, Gurman, Jashan, Jasmine, anyone tell me if not understood?
Sir, understand.
Okay. Still, I repeat one thing. Let me see the chat. Sir, understand. Okay, Gurman is saying. Angle can have any size. What I can say more, suppose the wheel has completed two rotations. complete 2 rotations, then the angle will be 720 degree. In the third rotation, suppose 80 degree more rotation goes, then the angle will be 800 degree, and so on. So angle can have any magnitude I have written above. Okay, angle can have any magnitude. One thing, and angle can be positive or negative also. Let us see now the right side diagram. Angle can be positive or negative also. How? We are saying that angle is the measure of rotation. Rotation can be in two ways. You know, the arms of the clock rotate in this direction, whether it is the minute hand, whether it is the hour hand or second arm, they rotate in this direction. Okay, this direction is known as clockwise. This direction of rotation is known as clockwise direction. And the opposite to this, the direction opposite to this is known as anti-clockwise direction. We are saying that angle is the measure of rotation. It means rotation can be either anti-clockwise or it can be clockwise. There are two directions of the rotation. So by convention, if the rotation of the object or wheel, whatever it is anti-clockwise, then the angle is positive. And if the rotation is clockwise, then the angle formed is negative. Is this concept also clear to everyone? Say yes or no.
Sir, yes.
Sir, yes.
Anybody saying no? I can repeat. This is the beginning of very new concept. Okay. So, understood. So, an angle can have any magnitude. It can be positive or negative. Can angle be zero also? Anyone tell? Anyone? Can angle be zero also? When there is no rotation, the angle is zero. In the beginning of the rotation, when the object is yet to start rotating, then the angle is zero. So all real numbers, whether positive, zero, or negative, are needed to express angle, the measure of angle, you can say, express the measure of angle. So I have completed this concept. You can take the screenshot. So that I can proceed to the next page. I am going to stop it. We will be doing a problem based on this. Let me share the screen. Is this problem visible? Evaluate
Sir, yes.
sine of 765 degree. How we will do it? We are to find this sine value of 765 degree. Let us see if we divide 765 by 360. We divide 765 degree by 360 degree. 360 ones are 360, but 362s are 720. So this will be, the quotient will be 2 and remainder will be 45. So 765-degree angle, how we will show in the picture? See, starting from the right hand side of the x-axis, I have already drawn this line. This is the x-axis, suppose, right side. Starting from this, we begin the rotation. In one rotation, we have completed 360-degree. But we have got the quotient 2. It means 2 complete rotations are there. So we continue rotating. We complete the second rotation as well. And after completion of the 2 rotations, we have the remainder 45-degree. That means rotation will continue till we form an angle of 45-degree. So here will be the final line. Means the final position of the rotating object. Suppose this is the point P. So what we do according to this concept, we write sine of 765-degree is equal to sine of 360-degree multiplied by 2 plus 45. That means the same concept. Dividend is equal to divisor into quotient plus remainder. What do you think sine of 765-degree will be equal to? That will be given by the coordinates of this point. Okay? Yes? Is this point clear? The point P which has been marked,
Sir, yes.
its coordinates will give, but the point P's coordinates will be same as if the angle only would have been 45-degree, isn't it? Because what happens if we complete one rotation 360-degree, we come to the 0 line back. Angle does not come to 0, angle does not become 0, but the position of the final line comes back to the 0 initial position. As we complete the 2 rotations, angle is not 360 or 0, it is 720 now. Angle has the size 720-degree, but the final line has got the position 0 again. So after that 45-degree angle more, we get the angle 765-degree, but the position of the line is same as the position it would have been if we have only rotated by 45-degree. Okay. So what is it? Means 360-degree angle makes no change in the value of any trigonometric ratio, because 360-degree rotation means coming back to the 0 line. Angle is not coming to 0, but sine value or cos value or whichever trigonometric ratio we want to find, it will start as if rotation is starting again. So just this is, we can write sine of 45-degree. I think this is clear. And if this much is clear, then it's over. Yes, anyone who can say no? Anyone who says no? Yeah. I assume you have understood? Sure?
Sir, yes.
Okay. So here is sine 45-degree. That means this is same as 1 by root 2. One chat is there. Okay, repeat. So when we found the angle 765-degree, we complete 2 rotations, 360-degree into 2. So come back to the x-axis of right side again. We come back to the right side of x-axis again. And remainder is 45 degrees. So we rotate further by 45-degree angle. So angle is no doubt, angle is not equal to 45-degree. Angle is 765-degree. But the position of the point which will determine the trigonometric ratios by its coordinates and the radius, that is same as the point which would have been there for the angle 45-degree. The angle 765-degree for the determination of the coordinates of the point is same as which is given by the angle 45 degree. So I hope this is clear now, Gurman. Gurman, Pushpreet,
Sir, yes.
Jasmine,
Sir, yes.
Jasmeet, and Arpan.
Sir, yes.
So it is just what we have to do. We have to, if we are given a practically what I tell the method, if we are given an angle of size greater than 360 degree, we divide that angle by 360 degree. We don't bother about what is the quotient, because quotient means complete rotations, number of complete rotation, which makes no difference. And we are concerned with only the remainder. So sine, in general, you can say sine of 360 degree multiplied by n complete rotation plus remainder theta will be same as sine theta. So here remainder is 45 degree. So we get sine 45 degree. And we know already its value 1 by root 2. So here I close the class. Okay, but in the evening I will be taking the class. 4 o'clock I will be putting the message, and that will be some kind of applications of whatever I am teaching. Okay, in
Sir, yes.
physics or somewhere. Okay, so I am now closing the class. You can take the snapshot before that, so that I can close. So closing. Okay, then I'm closing the class now.